Morning to everyone. So today we are going to see the problems on EMF equation of DC generator. So this is the first problem. Calculate the EMF generated by a 6-pole DC generator having a 480 conductors and it is driven at the speed of 1200 RPM. So the flux per pole is 0.012 Weber and assuming the generator to be lap winding and wave winding. So I'm requesting everyone, please go through the problem and read or try to understand what the data they given and what we have to calculate in the problem. So coming to the solution, so that is given data. So the first thing, if you observe that problem, calculate the generated EMF they're asking. So that is the generated EMF is equal to question mark. So the next one they give in 6-pole DC generator. That is the number of poles P equal to 6. So the next one they give in 480 conductors. The number of conductors Z equal to 480. So the next one they give in driven at speed of 1200 RPM. So the speed N equal to 1200 RPM. So the next one they give in flux per pole, that is 0.012 Weber. So the flux per pole pi equal to 0.012 Weber. So we know that the generated EMF is equal to pi n z by 60 into P by A. So, but they're asking, they given the conditions, assume the generator to be lap winding, that is the first condition. For that, we need to calculate the generated EMF. And the second thing, they're asking to calculate the generated EMF for the wave winding. So the first one is the lap winding. So we know that in the lap winding, the number of parallel paths is equal to the number of poles. So that is A equal to P equal to 6. Here the number of poles they given 6, that is equal to the A. Now the induced EMF is equal to pi nz by 60 into P by A. Here the pi is 0.012 and n is the 480 and z is the 1200 by 60 into P is the 6. They given the number of poles in the given data and A is 6. Why? Because 6 here means now they given lap winding. For the lap winding, we need to calculate the generated EMF. So in the lap winding, the condition is the number of parallel paths is equal to the number of poles. So after simplifying this equation, you will get the generated EMF is equal to 115.2 volts. So the second one is the wave winding. So for this wave winding, we need to calculate the generated EMF. So we know that the condition in the wave winding, the number of parallel paths A equal to 2, irrespective of its poles. So that is the condition in the wave winding. So that is A equal to 2. Now the generated EMF is equal to pi nz by 60 into P by A. So here the pi is 0.012 and n is the 480 and z is 1200 by 60 into P is 6 and A is 2. Why? Because now we are doing for wave winding. So in the wave winding, the number of parallel paths A equal to 2 irrespective of its poles. So after simplifying this equation, the induced EMF is equal to 365.2 volts. Sorry, 345.6 volts. This is the first problem. So I hope everybody is understanding. So the second one is they given the second problem. So in the second problem, they're asking a wave is connected to the armature winding, has a 19 slots with 54 conductors per slot. If the flux per pole is 0.025 Weber and the number of poles is 8, find the speed at which the generator should be run at given 513 volts. Also find the speed if the armature is lap connected. So this is the problem they given. So for that problem, we need to find how much speed. Okay, I hope. So please try to read the problem and understand the problem, what data they given. So what they are asking to calculate based on the data. So coming to the solution, given data, so it is connected wave winding. So the number of slots they given, that is the number of slots is equal to the 19. So and they are also given 54 conductors per slot. That means conductor per slot equal to 54. The next one they given flux per pole. That is flux per pole pi equal to 0.025 Weber. And they given the number of poles. The number of poles P equal to 8. So the next one, they're asking to find speed. The speed N equal to question mark. So where they're asking to find the speed, if the armature is lap connected. Okay, during this condition, we need to calculate the speed. So the next one, they given the generated EMF, that is easy equal to 513 volts. We know that the generated EMF is equal to pi n z by 60 into P by A. Now from this equation, n equal to Eg into 60 into A divided by pi z P. Why? Because in the problem they're asking to calculate speed. So generally we know that the generated EMF is equal to pi n z by 60 into P by A. So from this equation, we need n. Now n equal to Eg into 60 into A by pi z P. So the total number of conductors Z equal to the number of slots into conductor per slot. So in the given data, they given the number of slots and conductor per slot. But here the induced EMF is equal to pi n Z by 60. But here we don't know the Z value. You know the value of pi, you know the value of Eg, you know the value of P, you know the value of A. So based on the condition, you know the value of A. So we need to calculate the Z. So to obtain this Z value, that is the number of conductors. So they given the number of slots and conductor for slots they given. So based on these two things, we are going to calculate the total number of conductors. Now the total number of conductors Z equal to the number of slots into conductor per slot. So that is Z equal to the number of slots they given 18. So conductor per slot they given 54. So 18 into 54, total you will get 1026. So this 1026 is the total number of conductors. So on the condition they given, if the armature is lap winding, okay, in the lap winding, so we know the condition, the number of parallel paths is equal to the number of poles. So that is number of parallel paths A equal to number of poles P equal to 8. So in the given data, the number of poles P, they given 8. That is equal to the number of parallel paths. Now N equal to, so the induced EMF easy value they given, that is easy equal to 513 into 60 into A value. Here the condition is A equal to P equal to 8, that is 8. So by pi value they given, that is 0.025. Then this is the Z value, the total number of conductors. But in the given data they given the number of slots and conductor per slot. So based on these two, the number of slots and conductor per slot, we are calculating the total number of conductors, that is Z. So that value is 1026 into, you know, the P value in the given data, the number of poles they given, that is 8. So after simplifying this one, you will get 1200 RPM, that is N value. So during the lap winding in the condition. So the next one, if the armature is wave connected, so in the wave winding, we know the condition, the number of parallel paths A equal to 2 irrespective of its poles. So now the speed N equal to Eg into, you know the Eg value, that is 513 into 60 into, you know the A value. So here the A value is 2. Why? Because it is connected to the wave divided by, you know the flux value, that is 0.025 into, you know the total conductors, that is 1026 into You know the p values. The p value in the given data they given, the number of poles is 8. So after simplifying this one, you will get the speed that is 300 RPM. Thank you.